Welcome to the Elevate the Edge podcast. I'm Maribel Lopez of Lopez Research, and I'm joined with my co-host Joe Peterson of Clarify 360. If this is your first time listening to the podcast, welcome. Elevate the Edge is published bi-weekly. The podcast focuses on helping companies understand what edge computing is, how the market will evolve, and what you need to know to build successful edge computing strategies. Show notes and subscription links can be found at elevatetheedge.com/episodes. We hope you'll enjoy the show. Hello and welcome back to the podcast. I'm Maribel Lopez, founder of Lopez Research, and I'm joined here with my fabulous co-host, Joe Peterson from Clarify 360. Hey, Joe.
Hey, Maribel.
And this is Elevate the Edge, and we are so excited for me right now, and it is Sarbjeet Johal, and he is the founder and chief analyst at StackPain. Sarbjeet, how are you?
Good, Maribel. How are you doing?
I'm very excited to be here today and talking about one of my favorite topics, which is the edge. We thought we might talk a little bit today about the edge to cloud architecture and some of what we're seeing businesses achieve with it. So Sarbjeet has an extensive background in cloud architecture, pre-sales, data center, cloud migrations, all the things that would be really interesting when you think about how we're looking at this edge to cloud background. So he's directed Cloud Center of Excellence programs at Rackspace and Oracle, sought after analyst. We see him all over the place all the time talking about all sorts of cool things. So I'm just going to jump into it and ask you the first question. And that's a little bit around predictions and some of the things that we're hearing. Gartner, one of the big analyst firms in the industry, predicts that 40% of enterprise storage will be deployed at the edge by 2025, compared to, say, only 15% today. And maybe we could start with maybe a little dialogue around if you agree with this, and regardless of if it's 10, 20, 40, 50, some of your thoughts on how this redistribution of storage might affect what companies do with their overall cloud architecture. Just a small question.
I know it's loaded actually, and thanks for the introduction, that very flattering introduction. And before I start, I want to say hi to my good friend Joe. Hi Joe, how are you doing? Nice glasses.
You like my glasses too. I like yours too. So we're even.
God, you guys are like the cool glasses fan club, though, right? Because like Joe always has cool glasses, and it's just I got to up my glasses game. But sorry for the digression. Back to you, Sarbjeet.
No worries. Yeah, I learned that from Joe. I think it's a loaded question. Regardless what that number is, usually when I see those kind of numbers from Gartner or Forrester or IDC, I usually say, if its number is shown as 40%, I usually say, no, it's 39.9%. Just to make my point that we cannot really guess these numbers properly, right? So it's just a wild guess. I think they have a term for that, like intellectual study guess or something. They have a term for that. They assume
swag.
Yeah.
Silly wild ass guess, basically.
Yes, it is. Yeah. And I think these numbers they need to be seen as more like a trend prediction wise, like where we are going versus like absolute numbers, right? So yeah, there will be more storage at the edge as we are producing more and more data at the edge. Because why are we producing more data at the edge? Because we have more devices at the edge. And why we have more devices at the edge? Because we have more sensors. It's always, I usually say this, that it's always a convergence of technologies. It's never one thing which causes another industry to spur or take off. It's convergence of better compute, better networks, better storage, miniaturization of hardware. By the way, miniaturization of hardware and software is happening at the same time. I usually say that with microservices on the software side and making the chips smaller and the form factors smaller. It's happening all the time. So yeah, we will have more data produced at the edge and also consumed at the edge. And some data will never leave that edge. It will be used as input and as output. We'll process it there, and the output will be there as well, and we'll just guard it there. Yeah.
I know some people discuss whether or not they view edge and cloud as complementary technologies or competitive technologies. And I'm just wondering, do you think that the numbers we're seeing for cloud growth are actually cannibalizing existing cloud footprints? Or is there net new growth that's going to the cloud instead of the edge? Or how are you thinking about growth in both the edge and in the cloud?
Definitely, these are complementary. These are not competing technologies. What is the sort of breakdown of these? Like, what percentage of the total spend will go to edge versus cloud? Actually, that has to be seen. Edge is not taking the share from the cloud. I don't see it that way. Actually, it will help cloud even grow faster. That's what I believe. Cell phones are not very old technology, like the smartphones. They're not cell phones. Smartphones are, just, around 15 years now, I think, or 12 to 15 years. Since the iPhone came, we have started to produce a lot more data as individuals. By the way, I'm a big fan of defining the terms before we talk about those, with which we can actually, as we go on, what is actually edge. There's an industrial edge, there's a consumer edge, and if you put these two things side by side, there's a work edge. At work, we have our laptops and all these sensors and weather sensors in the buildings, whatnot. And there's under consumer edge, there's a lot of entertainment edge, if you will, like a lot of gaming consoles and whatnot, right? And transportation edge will be another big category in itself, I believe. The mobility edge, you can call it, right? And of course, there's industrial edge, industrial IIoT, what we refer to that as, right? So going back to your question, and by the way, what was your question again? I will do this a couple of times during this.
No, we were basically talking about whether or not we see there's growth at both the cloud and at the edge.
Yeah, definitely. So why I went to the smartphone sort of reference there was a study done, like for every 2,000 phones, I might be wrong, there are 1,000 phones, you need a server to support it, right? So because we are producing all that data, we need to route those calls. We need networks. We need central storage to send that data to somewhere else. Unless that data has to sit there, can you imagine just talking to yourself on your smartphone? I don't. So it has to go somewhere, right? And it has to go through these roadways, the digital roadways, and there are places where that data sits. And if not the data, actually, at least the metadata, a lot of metadata will be produced, and we need to store that somewhere for compliance reasons, for authorities, like the laws and regulations, like what we need to capture and when we need to capture these things. And of course, to make financial gains from it. All these companies are gathering all this data all the time, right? So yeah, in a nutshell, yeah, it's complementary and it will help cloud even more.
Sarge, I don't know why my mind drifted back to the Bez server. Remember the Bez server?
Oh my God, yeah. BlackBerry
right?
Bez?
Right? I remember my mind drifted back to that. Okay, let me first say I loved my roller ball on my BlackBerry. I loved it. I absolutely loved the fact that I could scroll. Yes, I'm saying it. So I loved what you said. Let's talk about terms. Let's define terms. And there's a new one. We are never short of terms in IT and new ones, right? So we're hearing this new term, distributed cloud. And it's supposed to be an architecture where multiple clouds are used to meet compliance needs, performance needs, or support edge computing, sort of what you were talking about before. Maybe, I think you were going to verticalization, and maybe it's sort of in that same vein. Are you hearing about distributed cloud as well?
Oh, yes, actually, we started calling it distributed cloud, but I mean, if you think deeply about it, it always has been distributed cloud, right? Um, um, Even the AWS itself, just one cloud provider. They have so many regions and availability zones, and now they're, as of last 3 to 4 years, they have regional data centers to serve the edge sort of workloads, right? I actually took a lot of notes. I thought our meeting was at 10, but it was at 11. So I got some time to prep for this talk. I don't know. The people who are listening, they can't see this on camera. Look at this, like all these notes I took to talk to you guys.
Okay, so you were a good student in school. That's what I'm seeing. That's exactly
I'm a student
what
of technology, actually. I usually say that. I'm a student of technology, and I take a lot of notes and I listen to you folks and Joe, you and Maribel and many other analysts out there and thought leaders and practitioners, so I try to synthesize all that. Sometimes I feel like a DJ, mixing things up and coming up with the new tunes and all that, new terms as well. So that the talking about the terms, the distributed edge is, I think it's descriptive enough term that it makes sense. I have said this many times in the last 4 or 5 years that edge will behave a lot like cloud did. The edge, the model, the consumption models at the edge, the pricing models will be mimicking the cloud as well at the edge. And I actually call edge itself the distributed cloud. It's just a smaller, tiny pieces of cloud, if you will. And literally, actually, even in real life, these clouds are they are of different sizes and they're floating around, like some are big, some are small, some make rain, some don't. Talking about money, So, I see distributed cloud and edge being the lines being blurred at some point. And talking about terms, like when we talk about the edge, just like cloud means different things to different people, the definition changes contextually. It's good thing. This is what my number one advice to salespeople. I've done a lot of work in pre-sales. Is that, and even in pre-sales, to the pre-sales people, is qualify what the other party on the other side of the table means by when they say something like cloud or edge. What do they mean by that? Because they mean different things than what you have been thinking all along. And then after an hour of discussion, you guys are like not talking about the same terms, and they walk away kind of confused. And you're also like, why didn't it call us, right? So I think the term edge, if you double click on that, there's edge device, there's a sensor, there's edge device, there's edge application on that device, right? And there's edge compute, and that edge compute can be sitting on the edge device, or it can be sitting far away from it. It can be wired connection to that compute. If you're sitting in a car or something, most probably compute is wired somehow. There's a compute part there. And then it can be over the air, right? So it can be WAN related sort of connection, if you will. And I've spoken to the APMA folks. It's a Canadian consortium for auto industry. They talk about V2X, vehicle to all other things, from the car to the road to the light poles and all other sensors, and the traffic lights versus the lights, which are used at night, and the roads and edge of the road, if you will, literally, and getting all that information when that car moves on the road, and also inferring the people being there, the dogs and cats and other things, trees around you. So all that stuff actually needs compute, And then that compute, where does it sit, matters a lot. How reliable that is. Are we always connected? If you go into the more sort of tech side of things, there are considerations we have to take into account. Can we operate these edge devices when there's no internet connection, when they're not connected to the back to the central repository? On that note, this is my very sort of firm understanding. Actually, when I say firm, I believe like very deeply in this. That I say that the control plane of these devices will sit in the cloud. So we will send what these devices will do, or we will manage these devices from the cloud, from central places. We will push the code or the bits or whatever you call that to control these devices from the central places. And then these devices in the field will get very consistent sort of application, if you will, distributed to these devices. Otherwise, it's a nightmare to manage these billions of devices and maybe hundreds of billions of sensors, right? So the control plane will sit in the cloud. I know I'm going all over the place here in my talk. What I'm trying to say is that yes, there's a lot of data locally there, but a lot of control is in central place, and a lot of metadata will sit in the central place. And also it's not, by the way, another thing I usually say is like broad strokes don't serve anybody, like when you're painting, So in our talks, like we have to qualify these statements. When we make a statement, make sure we qualify it with some examples and stuff like that. On that note, I think the use cases will differ. The architecture will differ by industry for sure. If you're healthcare, you need, it's a matter of life and death. If somebody's playing, GTA, that's Grand Theft Auto or something like that game, that's the only one I know, I guess. And if that game doesn't function for a few seconds, it's not an end of the world. Nobody's dying, right? But if there's a sensor, the pacemaker is connected to the internet somehow, and then pacemaker doesn't work and somebody can die, right? So there are different use cases and different that means different architectural considerations for making a device work locally independent of the network. And some devices will be connected all the time. Some devices will be connecting once a day. Some devices will connect 5 times a day. I just did the experimentation before this talk. The CD works flawlessly if there's no network. I just say I put myself in the airplane mode and I was able to talk to it and it's typing flawlessly. So earlier CD was not working like that. It will send your voice to the cloud, and so a lot of inference will start happening at the edge. I will stop there. I can talk.
No, thank you for the insight. I appreciate it. I know that you, and I'm jealous, I know that you recently attended KubeCon, and there was like a great turnout and lots of buzz, like hugely increased attendance at that conference. And there's an emerging architecture called Cube Edge. You're probably familiar with it. And the Cube Edge architecture consists of cloud, edge, and the device layer. And to your point earlier, the control plane is in the cloud, and the edge nodes are at the edge. So in your opinion, what are some of the advantages of this architecture for edge deployments?
I believe the advantages of this architecture, or this, they have put a bunch of technologies under that name, Cube Edge. It's Kubernetes at the edge, actually, basically, right? So the benefits of Kubernetes is consistency, right? In the absence of having any standards, this is the pattern I've seen. In the absence of having any standards, open source ends up becoming a standard. And in this case, that happened. Luckily, we got lucky, actually, that this time we got a very mature product, mature open source project, which came out of Google. It was time-tested technology. It was Google's Borg. what they call it inside, which, spits out billions of containers every week and then shrinks and expands based on the regional needs of when they do crawling of the web and they do indexing of the, search keywords and all that stuff, what we use Google for, right? More than 2 billion people use that stuff, right? So it was so mature that we just got it as is almost. And it was generic. It's a genericized version of that, actually, by the way. It's not Borg itself. It's a subset of that. So, and there are very miniaturization versions of that, actually. That's what I experienced at KubeCon. I'm glad I went there. There's so much innovation going in open source. It's mind-boggling, by the way. Okay. Another thing I will throw in there in my talk is I have said that long ago, many times, that technology is like medicine. Every pill has a side effect. And there are side effects of us cooking up too much open source as well. That's a security threat, and the containers are contaminated. Most of them have lot of security vulnerabilities. There's a lot to chew on in the open source side, but I won't go into the tangent here. Yes, to answer, coming back to your question, it's a great way to make sure that we are not reinventing the wheel. We are industrializing the compute at the edge, if you will. And once you go to the industrialization, it's hard to go back. It's hard to make our own, shoes at home these days, or our own cars at home and our own, power generators. We don't want those. Once you industrialize something, it's hard to go back. And for that reason, I believe that I'm a very big sort of pro-cloud person. You must have seen me talking about having debates with people who think, oh yeah, the repatriation is happening and all that. No, we can't go back. We never go back, actually, almost never.
Always move forward. So something you said actually made me want to jump in for a quick question. And that's around, we were just talking about security and workloads and all those things. And I'm wondering if in your mind, a build once, run anywhere mindset won't work for all workloads. It sounds like we were just talking about some differences in latency, some differences in reliability and other things. So what are your thoughts on that?
Yeah, build once, run anywhere. In other words, we're talking about portability, right? So it's a dream goal of ours, right? And I usually say that before portability, interoperability is the more realistic goal, more practical. So yeah, there are some things which build once, run anywhere. There are in certain use cases that's true, but in most cases, that's just a pipe dream most of the time, I believe. So even our simple, from our core computing sort of habits, like even normal editor, we have on Windows, we have different editors, Notepad and whatnot, the 500 different types on third parties, and on Linux is Vim, and other people are very religious about the editors itself. You have to write code in and to write some text in, So yeah, it's the heterogeneity. No, okay, you got my point. So the polyglottism and the heterogeneous nature of technology will exist forever, I believe. When I say forever, for a long time to come. In ours is an industry where standards are hard to find, and as I said earlier, in the absence of standards, open source ends up becoming standard in some parts of the whole big computing industry. Yeah.
Well, thank you for your insight. It's always valuable, Sarbjeet. We always end the podcast with a fun fact. So it could be non-technical, it usually is. And I wondered if you could share your fun fact.
Oh yeah. Actually, it's fresh off the press, almost like, in last week or so. We know that FTX exploded, right? FTX went bankrupt. It's a crypto exchange, right?
Yeah.
By the way, I on the funny note, I say, what's FTX stand for? It's F that experience. Access for
I did not know that. Oh my gosh. Okay.
No, actually, this is my funny observation, sort of abbreviation, explanation, if you will. But no, the fun fact is this, that the CEO or the founder of that exchange, his name is Bankman-Fried. So it's a very funny name, I think, because he fried so many bankmen.
Oh my! Look at you doing a pun joke, or a dad joke. Either way, right?
Dad joke kind of thing. Bankman-Fried is his first and last name. Bankman, first name and last name Fried. And I just tweeted, actually, he lived up to his name. He fried few people from the banks.
Oh my. Well, there we go. There's our fun fact. Well, Sarbjeet, it was lovely having you here on the podcast. Thank you so much for your insight. Really appreciate it. And we'll see everyone next time.
Thanks, Joe. Thanks, Maribel. Appreciate it. Keep doing the great work. I hope to see you at the event soon.
We are going to see you at reInvent. All right. See you soon.
All right. See you. Bye.
Thanks for listening. If you enjoyed this show, please subscribe so you can easily find us again. Follow us on Twitter at Maribel Lopez and at Digital Cloud Gal, and on LinkedIn. Links to our social profiles, show notes, and ways to listen to the podcast can be found at elevatetheedge.com.